All right, so today you're learning how to determine if a function is even or odd. Now, it is related to the exponents, but that is not the only criteria. So a function can have an even degree, but not be even. So we're going to spend a little time in class going through that, understanding the difference. So just realize when we call it an even function, it's just relating to this criteria that I'm giving you right now. So if you remember last year when you reflected something through the y-axis. So when you reflected something through the y-axis, you changed the sign of the x. So if you were on reflecting through the y-axis, so say you were reflecting this point through the y-axis, it would end up over here. So the y coordinate is the same. It's still on the same level. So this point is just going over here, but the x coordinate changes. It changes from positive to negative. So that's what an even function is. It's basically if you have a function that you can, if you reflect it, that is the greatest line I've ever seen. If you reflect it through the line x equals 0 or the y-axis, and it's symmetric, so it's the exact same function when you do that, it's considered an even function, right? That's what an even function is. So, no, you didn't know that, but that's what it is. That's what we consider an even function. If you remember from last year when you reflect something through the origin, so if you reflect something through the origin, so for this one, this point over here would wind up through this point over here. We won't go through the basis of the slope and how it's the same and all that garbly goop. But the basic idea is both x and y are changed, meaning the sign for both of them is changed. So if you have a negative x, like if you change the sign of x, you also change the sign of y to reflect something through the origin. So if something is symmetric through the origin, so meaning if it's exactly the same, like this point here becomes this point here and vice versa, like they just switch spots and it's the exact same function, that is an odd function. Okay, so on a graph, it's kind of easy. So for an even function, you can just simply look at it and see if it's symmetric through the line x equals 0 or the y-axis. Odd function, you just flip around. You can just, turn it upside down. Turn upside down. I probably say this all later, but I probably should have read it. I'm a really good teacher. Anyway, so the way that we say this in function terms, so you did this with points and triangles and stuff like that, but hold on. Okay. So this is what is actually happening. So if you plug in negative x, you get this exact same function back out again. So that means if you change the sign of x, you get that the function doesn't change. That's what an even function is. Okay? And then we're going to show you how to do it. It's very simple, but I just want you to understand. For this one, for odd, if you plug in negative x, y changes also. Remember, f of x is also y. So if I plug in negative x, you get negative y, okay, or negative of the whole function. So this is how it works. Let's go through it. KK, sounds awesome. All right, so this is what we do. So we have to determine if they're odd, even, or neither. So it could be neither. Not all functions have these qualities. So the process is we plug in negative x. Okay, so plug in negative x for x. Do the math. So I'm going to plug in negative x everywhere. Yeah, that's right. Everywhere that there's an x. Okay, do the math. So when I do the math here, any negative to an even power is going to be itself. So it's not going to change. Any negative to an even power is going to be itself. So that's what f of negative x is. And then what we also do is change the sign. So basically figure out what this negative f of x is. So maybe slightly different. We're doing this. Okay, so we're going to figure out the three things that we have to do. So the three things that are going to make this easier are, we're going to figure out what f of x is, which is given to you. We're going to plug in f of negative x, and then we're going to figure out what negative f of x is. That's it. So negative f of x is, all that means is I'm putting a negative sign on the outside of this whole function. Okay, so then I just multiplied in negative x to the fourth plus 2x squared minus 3. So that's negative f of x. And then you just see if any of them are equal to each other. So this one and this one are the same. So f of x is equal to f of negative x. So that criteria says that it's even. And that's an explanation. It's perfect. That's all it has to do. All right. I know this is really weird. And why you use it, please don't ask. I have no idea. So it's really just very rote if we do it this way. Very little thinking involved. So we figure out what f of negative x is. We plug it in. Okay, do the math. So negative x to the third power is going to be negative x to the third power without the parentheses. Because if you think of this as a -1 times -1 times -1 is -1. So we're putting that exponent in there to see what it is. And 6 times negative x is negative 6x. So right now, this is what whatever, you know what I'm saying, is f of negative x. The other thing that we do is we figure out negative f of x. So meaning we just put a negative on the outside. I'm excessively doing these steps. Obviously, these steps are like putting this piece in isn't necessarily. You could just go right to here. Negative x cubed minus 6x. And then you see if any of them are the same. So we have 3 of them to choose from. 1, 2, 3. Well, these two are the same. So if these two are the same, f of negative x equals negative f of x, then we know it's odd. Woohoo! And the last one, I'm guessing this one's neither, but, you know, I just made this, so who knows. I'm going to switch to blue. All right, so we plug in f of negative x. There is a shortcut, but this is how we do this algebraically. Hopefully by the time we're done doing this, you'll be able to tell just by looking at the function if they're odd, even, or neither. But to show the work algebraically, which is what we always expect, you have to do it this way. Okay, so it's an even exponent, so this negative here becomes a positive. It's an odd exponent, so the negative here makes this negative 2x cubed, and then negative 3 just stays the same. All right, so then what's negative f of x? So negative f of x would be negative x to the fourth plus 2x. All right, so it's negative x to the fourth minus 2x cubed plus 3. Now, are any of these the same? So this one has negative, negative, positive. This one is positive, negative, negative. Yeah, none of these are the same. So if nothing is the same, it's neither negative, it's neither odd nor even. All right, I hope it wasn't too confusing, but it'll be fun later. Have a nice day.